Well, officially, welcome to this webinar. My name is Martin. I'll be your host today. Actually, for some of you might know me, actually, I've been working with Crewform for 12 years now. And I mean, when I started Crewform, we're 60 people, or now around 600 people. So it's my role has changed, but a few years I'm a mechanical engineer myself, and 2 years I've worked with metrology technologies, but also on the engineering and product development side since the last 5 years. So I have a mixed background. And actually, the real person you want to listen to today is Cédric Chéné. And Cédric Chéné is a graduate from the Aerospace Engineering School in Quebec. And in the last 8 years, actually, has been really focused on the GD&T methods and techniques related to that. And he's worked a lot in the transportation and the it's the transportation railway industry and aerospace industry. So that's pretty much his specialty, everything that concerns dimensional management. So if we get to the next slide, actually, I'm going to talk about the agenda. So roughly what we want to go through today and the timeline we're going to take. So first, what we're going to do is just introduce you to what Crewform engineering is relative to Crewform and Amatec, and what we do, service software and everything. And then we're going to go through, we're going to get into the core presentation with the origin of GD&T and the current manufacturing framework and the environment in which most of you work today. And so as a context, and then after that, we're going to go through the 6 steps of dimensional management. So pretty much how we use dimensional management and where GD&T fits into that, metrology fits into that. So, and then we're going to have a case study. And at the very end, we're going to go through the questions you guys will have through the presentation. So don't hesitate, just ask your questions all along. You can take note on the slide. If you have a specific question on the slide, we'll come back at the end to it and try to answer most of the questions you guys are sending us. Depending on the volume. So normally this should take about 30 minutes. That's the objective we have. And after that, we're going to go through the questions. So if someone doesn't have any question, we want to go through the whole presentation so we can leave. And after that, for those who have questions, you guys can stay and discuss with us about your different questions. Crewform Engineering, what it is? Well, it's first of all, it's a great team. It's a great company. It's a division within the Crewform. It's been founded in 2002, Crewform, and pretty much Crewform Engineering and the service offer was the first thing we've offered. So now today we're about 185 technical experts. Mechanical engineering is pretty much the core of what we do. So, but we have also different service offer we're gonna see later on in the presentation. And we have 4 different offices, 3 in Canada, Lévis, which is Quebec City, Laval, Montreal, and Saint Clair, and then we have an office also in Irvine, California. And we're part of the whole Crewform family and the Amatec family. So if we go on the next slide, actually, we're gonna see. So you see on the right, if you want to come back, if you pause maybe the presentation, we have Amatec on the top. So Amatec in 2013 has purchased Crewform, as bought Crewform as a whole, and Crewform has mainly 2 divisions. So everything that relates with technology. So a lot of people here today know about these technologies and a few other optical metrology technologies on the market, I guess, or a reseller or use that. Engineering service is really a different channel. What we do is develop products for a customer, help them and manufacturing solutions. So we help them tackle some of their challenges relative to assembly or product design. And and then there's Amatec. So if we get to the other slide, where we're part of a larger group of company. Amatec is a U.S. public corporation, so it's pretty much like 50 company like Crewform within the whole company, and then we're part of a division which is called Ultra Precision Technologies, and that regroups a few 6 or 7 companies that are really developing high-end measurement technologies like Crewform is as of today. So, and Amatec is like 15,000 employees, 150 locations. So you get a big picture, a big corporation established pretty much in all the developed countries with sales over 5 billion. So that's the context. That's who we are and pretty much what we do. So in terms of what Crewform Engineering does, actually, I don't want to go through all this, taking too much time. I just want to give you an idea maybe of our mindset and why this makes sense with Reform, the technology, metrology. So we design products for a customer and we help them achieve better products and also industrialize those products. So help them to manufacture that efficiently and help them develop toolings and everything that is related to being able to manufacture a train or an aircraft, or it could be a recreative vehicle or recreative products vehicle. So we design, so we bring idea to life. We do engineering, so really that's the core of what we do. The most of our time is spent on developing, making drawings, 3D modelization, and simulation is what we do also. High-end services and simulation, we have a team of 15 people that only does that. So it gives you a picture, and there you see in the middle, dimensional management is actually something that goes a bit in all these three, where it works with all the different other service we have, and also works with the portion of metrology we have at Reform. It takes it's an offer that takes over different and has to work with all the different departments from the start of a product, where you have ideas of what you want to do. You gotta have to think about dimensional management to delivering at the end of your production line the product, make sure it's the quality is there and it's is as expected. So dimensional management is pretty much everywhere around your product development and life cycle of your product. So, and I guess this is before this is Cedric is going to take on from this point on the presentation. But before we do that, actually, just to make sure you guys are still awake and listening to what I'm saying, we have a two question survey. Actually, we just want to have a better idea of the type of people that are present at this webinar. There's a lot of people actually present. So first question is, and please be indulgent, I have to click here to process this whole question. I'm going to send you a question. It's going to show on your screen, just answer, and then I'll show you the results so you can have a better idea of the type of person present at this webinar. So here we go. So normally you should see on your screen a survey question where you guys can answer, and I see people voting, and that's great. I'll let everybody make sure you guys vote. Try to capture as much as possible. There you go, I see people voting. Give you a little 20-second more. Okay, I think we have a trend, definitely. So the question is GD&T part of your product development processes? So, and I'll close I can close the poll. Actually, I see vote casting in still, but it's pretty much the same trend. So I'm gonna close that, I'm gonna share with you. It's approximately, 80% of you guys today are pretty much include GD&T in part of your product development processes, which is really a good news. I think that's part of where you need to be today if you're a modern company and developing products that are good in quality and reliable. So I have another question coming right after that, which is, and you'll see why we asked the question actually is I'll send that on. You should see it appearing. So have you ever heard of dimensional management before? And I'm curious to see the trend on this one. Oh, so the vote is casting in, great. And after this question, there won't be any other question for the exam. You guys should be good to go through the whole presentation. For those that don't have the right answer, though, you might be kicked out of the webinar, so make sure you're casting the right answer there. Okay, so yeah, like half of the people has voted there right now. I'm gonna show you the result. So have you ever heard of dimensional management before? Actually, I'm quite positively surprised of the answer. So like pretty much half of you did hear about dimensional management before, which is great. This is not necessarily what we see in our global portfolio of customers. But I guess today we have a more metrology and dimensional management sensitive audience, which is good. So Cedric can make sure he present maybe more into details. And so glad to hear that. I guess it's not a mystery for everyone. For those who don't know, well, actually we're gonna take time to explain what it is compared to or relative to GD&T and metrology. Well, I guess I'll let Cedric know, but just for you to know, today it's an introduction to dimensional management. So there might be other webinar coming up with more deep technically So in your question, and at the end of the webinar, when you're going to close everything, you guys can answer a survey with few questions. If there's some topics that you would like us to go deeper on and make a webinar in the future, make sure to let us know. It will orient our content development for our future. We have a lot of content. We have to adapt it to make it in a short webinar. So make sure to let us know if there's any specific topic on the whole thing you're going to see today that seems more interesting or mysterious to you. Well, thank you. I'll let Cedric go on from here.
So hello everyone, so welcome to our webinar on dimensional management. Like Martin said, since this is our first one, it will really take the form of an introduction to the subject. So that means we won't go into very specific technical detail because we really want to show an overview of everything. And since there's a lot to talk about, there's no other choice than to summarize quite a bit. So if you joined this webinar, you might already know a little bit about the subject, like we've seen on the poll also. So it won't be breaking news to tell you that GD&T language is a big subject for many manufacturing industries, but we sometimes forget that GD&T is just that, a language. So this is the first nuance we want to bring to the table. So while GD&T is the language that allows us to communicate, dimensional management is really the study that will allow us to define correct GD&T requirements. So to expose that, we'll go take a very quick look into the origins of GD&T. So it's a bit hard to attribute the whole field of dimensional management to only one person, something that was developed quite gradually by multiple persons, and it was during the war, so we might have lost some information. However, the first written proof that we can find is a book written in 1940. So the name of the book is Notes on Design and Inspection of Mass Production Engineering Work. It was written by a guy named Stanley Parker, and Parker was working in the production of submarine parts, so more specifically submarines torpedo. And during that time, there was a critical need to dramatically increase the production rate of just about everything. So we needed to find a good way to do that, and this came with a bunch of challenges. So first, we needed to avoid rejecting good parts, right? But we also wanted to avoid putting bad parts into service. And on top of that, we wanted to make sure that most parts were interchangeable. So one of the reasons for that is that we wanted to facilitate the maintenance of vehicle on the field. So if you can take one part of a vehicle that is out of service and use it to repair another vehicle, that's a big advantage. But the most interesting part that we can learn from that book is that it didn't even mention GD&T symbol. So the book talk about the concepts, but when it's time to describe the geometry on the drawing, they use text and notes. So I think there's two things we can learn from that. So one, the concept came first, then the language appeared to ease the communication of all of that. And second, when you are unsure about the perfect way to describe something on the drawing, a well-written note can still be used. So fast forward to today. So the context have changed quite a bit, but you'll see that the challenges we had to resolve remain quite similar. So we can identify three main trends in the modern manufacturing industry. First, we have the decentralization, and then we have the push for more modularity in the design, and of course, automation. So most of the industry are either already working with at least one of these concepts or will be in the very near future. So let's talk first about the decentralization. So this is when we have a product that might have been manufactured in only one big manufacturing sites in the past, but we now want to explode the production to many smaller production sites. There's a lot of reason for why we might want to do this. So maybe we want to specialize the manufacturing of one part of the product in one area to bring down the cost, or maybe the country where we want to sell the product required a certain portion of it to be produced locally. So, but this is something that is happening, and it brings with it its share of challenges. Then we have modular design. So this one brings a lot of advantages to the end user of the product. So one of them is that it allows the product to be upgradable. So for example, if you want a new function, you can just buy the upgrade and it will fit. It also eases quite a bit the repairing of the product. So if one part of the product break, you can just replace that one part and be done with it. But it doesn't only benefit the end user, it can also allow for a dramatic reduction in the design costs. So for example, when you want to put a new product with new functionality to the market, you just have to redesign the part that have changed and avoid spending money redesigning the core that remained unchanged. And the last one is automation. So everyone is more and more familiar with automation, and I think it's there to stay. But by the way, when we talk about automation, we don't only mean a robotic arm. We also include any kind of tooling where a part or an assembly needs to be located precisely every time. And the challenge with that is that part must fit every single time. So there's almost never the possibility to compensate and adjust every single part individually when we talk about automation. So when we look at these trends, what do we see? So first, we need to avoid sending bad part to the main assembly line when we have decentralization. Then we need to ensure that part would fit all the time in our modular design and our automated assembly line. And of course, we still want to ensure that we don't lose money by throwing away good parts. So even if the contexts have changed, the challenge remains quite similar, and that's why we need to understand GD&T and dimensional management. So here are all the steps we are talking about. So if you are familiar with one or more of these steps, you will understand that this well right here represent a very, very broad range of subjects. So since today, the goal of today's webinar is to show a rough overview of all of these steps, we'll go through them one by one in the next slide using very simplified examples. Like Martin said, in the future webinar, we'll focus a bit more on a specific subject, so we'll be able to dive a lot deeper into the detail of that particular subject. And also, there will be a question period at the end, so feel free to ask any specific question, and we'll try to orient our choice of subject for the next webinar using this. So the first step happened in the design phase. So what we need to do there is to identify requirement, but yeah, which requirement are we talking about? So the requirement we are talking about is most of the time a characteristic of the product that we want to have at the end, characteristic of the end product. So there can be many types, and usually it's something that involves multiple parts and systems. So that's the kind of requirement we are talking about. Can also be an assembly requirement. For example, if we want our product to assemble easily, that's still a characteristic of the end product to be assemblable. But so because of that, we will also find functional requirement on some sub-assemblies. These requirements are there to ensure good fitting of the parts during the assemblies. So one very important thing that we need to keep in mind when we are defining the requirement is that they need to be measurable. They need to be objective. So if one requirement, for example, is something like the gap must be aesthetically pleasing, that's not something we can analyze. So at these steps, we want to make sure that all the requirements we are defining are defined with an objective value, and ideally they should have also a tolerance associated to it. So we announced this webinar saying that we would be using a concrete example to go through these steps. So what we'll be using as an example is the front suspension of an ATV vehicle. So when we look at an ATV vehicle, here are some example of the product characteristic that we could define as functional requirements. So first we have all the overall dimension, like the width, the length, could have other. We also have all the things that can affect the dynamic behavior of the vehicle, like the tow, the caster, the camber. But if we look at the way they are defined here, like we just said a bit earlier, this is not enough as a definition. So this is a bit more like something we would like to see. We have a starting point, we have an endpoint, and we have a tolerance value associated to it. But in a real world scenario, we might still want to improve even further on the definition. For example, we still don't know exactly which feature constitutes the center of the front frame. And from the image, even if we can assume that the arrow is pointing to the interface between the structure and the wheel, we still don't know exactly what surface that is. So that being said, this requirement will be good enough for our example of today. So once the requirements are defined correctly, we can start analyzing everything, how everything is put together. So sometimes, like in this case, it will be quite obvious, but it can also be a big source of questioning. For example, if there's more than one way a part can be installed, or if a part needs to be located with some kind of tooling and the details about how the tooling should be used are not clear, it can be quite challenging. So at these steps, all of this needs to be clarified and documented. The reason for this is because these information will be used later in the analysis step, and if they have to change, the analysis will have to be started all over again. So these steps, it can also raise a question about different assembly strategy. So when that happens, there will often be more than one valid solution. So the way to proceed in this case will be to assess the pros and cons and find the best one according to your specific needs. So for example, here we have two different scenarios on the screen. So one of them where we don't have any adjustment possible on the blue parts, and one where we do. So if we look at the first scenario, so this might improve our production rate since we don't have to implement an additional station to adjust everything. So you install the part and everything should align together nicely and by itself. But on the other side, the product will be a lot more sensitive to variation. The tolerancing on the part might become more critical, and it might even drive the cost of the parts up a little bit. In the second scenario, we have the luxury of adjusting the blue parts. So it will make the whole assembly a lot less sensitive to the variation since you can adapt each one individually, but you will have to plan for a station where this adjustment will take place. And you might even have to design some kind of special tooling to do that. So depending on the specific of the situation, either one of the scenario can be the good answer. But like we said a bit earlier, one thing that is important is when we find a way forward and when we identify that way forward, we should do our best to try to stick to our choice that we have made, because this will also have an influence on our analysis. So the next step is the analysis. So once we have a good understanding of how the product is put together, it's time to do the variation analysis. So at these steps, we want to evaluate our designs and also the assembly sequence. And we want to make sure that this will allow us to meet the functional requirement that we defined earlier. So what we'll do is we'll choose one by one, we'll choose one of the functional requirement that we defined earlier, like in this case, the positioning of the wheel in width. Then we'll use the relation between the parts, the one that we just identified in the previous steps. And with that, we will determine the specific dimension of each component that will have an effect on our target. So what we see on the screen is a very simplified example of that. It's just to show the principle, but regardless of the complexity of the analysis, the concept will always remain the same. So we use the relation between the parts to identify a list of dimensions that will have an impact on our target. So once all dimensions are identified, it's time to attribute manufacturing tolerance to all of them. So the goal here is not to define the tightest tolerance and try to meet the target at all costs. So we just want to see if the design can meet the target with standard manufacturing requirements. So putting super tight requirement on paper that will be impossible to achieve in real life won't serve you any good at this point. So what we'll want to do is put a realistic value for each of them according to their manufacturing capability. And then the goal of that is to get a value that will be represent as close as possible what you will actually get in real life. So one of the things that can make everything trickier in more complex assembly and in the analysis for more complex assembly is that at some point requirement may start impacting each other. So that can happen if you have dimension in one part that can influence more than one target requirement. So you change something there and it's affecting something other over there. So we need to find a good combination that will ensure that we meet everything. So, and all of this while we ensure that we put tolerances that are still realistic in regard to the manufacturing process of each part. So at these steps, this is where we can identify a lot of flaws in the design that would have been only found later in the manufacturing process. But this is good. It will be a lot cheaper to correct them right now before the production is started than to debug everything during the production after all the tooling is made and the manufacturing method is defined. So next steps, once we are satisfied with the work that I've done in the previous steps, we are satisfied with our analysis, we can use the information to communicate all the requirements on a drawing. So this is where GD&T come into play. We will use the information that we gather in the assembly strategy to define functional data, and we will use the latest value of our variation analysis to define the correct tolerance value. But one question that may arise at that point is why using GD&T requirement for that? And I have a small example. It's not a perfect example, but it's good enough to show one of the things that can't be done with 2D linear dimension. So here we have two linear tolerances. So one horizontal for the position of the holes in length, and one vertical for the position of the hole between themselves. So both tolerances are plus or minus 1. But if we put these two dimensions at their maximum tolerance value, we'll see that the distance from the theoretical perfect nominal center will be 1.4. So if we analyze that the maximum deviation from the nominal should be 1, it should be true regardless of the direction of the deviation, and that's not what we are seeing there. So the tolerance zone that we would like to see, that we would like to describe on the drawing, should look a bit more like that, a circle. And defining a circular tolerance zone with 2D linear dimension is not possible. So if we look at the example here, all the parts that would have ended up in the corner where are the parts that would have been accepted if the part would have been controlled with 2D dimension, but the deviation from nominal would have been greater than our established maximum of 1. So this is just a very quick example of the things that can't be done in 2D linear dimension, but there's a lot more of them. And that's also why Parker at the beginning, when I was talking in the origin of GD&T, they needed to add text and notes to the drawing in 1940 before GD&T symbols came into existence. So the last thing about GD&T is that it's a common universal language. So no matter where you are or who you are, you will understand the specification the same. So once all the work is documented with GD&T on the drawing, you have all the tools you need to manufacture, to communicate exactly what you need to all the manufacturing sites and start the production. So the next steps happen during the manufacturing process, and it's the inspection of the parts. So GD&T was first used to communicate the need, but now it's used to control the part and assess whether or not each part will allow us to meet the final requirements. So this is the target we evaluated in the analysis step. So if we have done a good job of documenting everything from the start, we can even know right away which final functional requirement will be impacted by a specific dimension that is out of tolerance. So this is where the last steps comes into play, and this is the impact analysis. So here we have an example of an inspection report where one of the dimension on one part is out of tolerance. So if we talk about impact analysis, let's try to evaluate the impact of this dimension on functional requirements. So if you look at this, so if we kept the analysis that justified this tolerance in the first place, we can take that out and re-input the true number in the analysis to evaluate the true impact on the functional requirements. So most of the time, this is what we care about. The final functionality of the product right here, not the individual dimension of each part. And in that case, we can see that one dimension that is out of tolerance is not necessarily a direct indication that we will fail a functional requirement. It's just an indication that we need to take a look into it. But yeah, in that case, unless all dimensions that we see here were out of tolerance and also in the wrong direction, we should be able to meet the final requirements. This is also a reason why we might want to include some statistic in our analysis, but that would be a subject for an entire other webinar. So this is about it for the 6 steps of dimensional management. So just as a summary, here are the key takeaway for each of the 6 steps. So first, during the design phase, you need to define good requirements. Then you need to define the links between the parts and answer all the questions about how your product will be put together. Once that is done, you can study the effect of the variation on individual part on your requirement. And all of this will then be used to define acceptable tolerance on the drawing using GD&T. So then when the production starts, the information on the drawing will be used to inspect the part, and finally, the result of the inspection will allow us to evaluate the impact of the deviation on the final functional requirements of the product. So Martin, do you want to?
Yeah. Well, actually, before we get to the other slide, just to take maybe more to the floor reality things that we're seeing a lot, like in the years working for Careerform. We have some customers that that use GD&T actually on their drawings. They have metrology equipment, and so what we see sometimes is that the part, I mean, the functional requirements is really a part where sometimes it's a bit loosey there. I mean, the functional requirements are stated clearly, but then how to convert that into realistic or effective tolerances on a drawing, that's where it's a bit more tricky. So what we could see on the market sometime for a customer that we've been working for years is that, and they make good products, but they would have like a part going into production, and when they would make the inspection report on that part specifically, they would call it out of tolerance. But the thing is, the people assembling that on the line for a high volume of assembling find out that actually the part, even though it was out of tolerance, would be still functional. So it's not and my purpose there is that the customer what they've done there is that they would take that, say, well, you know what, the batch we've received 30 parts, we've made a statistic study on that the batch, a lot of them is out of tolerance, but still they all assemble correctly, and it's a gear set that would be working properly. So they would go back to the engineering office and say, look, here what we've measured, you should change your drawing requirements because the functionality of the product still works even though we're out of tolerance. So it's not a sequence, it's not only sequential in one direction, it goes back around, and the feedback you get from your inspection and the functionality of your product, so validating that it works, get back to the engineering portion of the company to change how they translate their functional requirement into dimensional requirements on the product. So, and this is typical. It's not, I mean, it's stuff that we see every day actually. So sometimes it's either that engineering is too severe, they make like, I mean, they put like dimensions, the tolerances that are so tight that it doesn't really make sense. So it costs a lot for the company to do manufacturing. Their supply will charge them more to be within these specifications, even though functionally you don't necessarily need that. So having the proper balance between your tolerances is something you get very experienced by introducing GD&T and having feedback from your production. So more you do, better you get at it, and the most feedback you get from every stages, better you are at being effective and efficient also. So if we get on the last slide, actually last slide, well, not the last slide,
The last slide is
that, but yeah, so the conclusion basically, if I mean, I just basically talked about that, but dimensional management is more than just the drawing itself. So it's not just looking at drawing and interpreting the drawing. It's a process which is a bit larger than that includes different aspects, and all of them are important. So, and if you and what's important is that to the take-home message here today is for you to know that we Careerform, I mean, technology makes metrology equipment that are they're used really into the inspection process of the cycle, but Careerform engineering covers the whole cycle there. So all the 6 functions you see on the screen or the right of the screen. So that's what you have to think about, and we can help from the idea of developing a product to the in-service support. So if you have a product which is on the market and you get like a problem because you have a certain wearing, premature wearing on certain components, well, it might be related to a dimensional problem. Well, we can help you with that. Maybe it's not related to that. So, and that's part of the root cause analysis of FME or stuff that needs to be done before. But if it's a dimensional problem, you think, well, we can support you with that, changing your engineering, making sure when you assemble and all it works together, you're going to have the product you were expecting to, or your customer is going to have the product you're expecting. Well, don't wait until it breaks to call us. I guess you see here, if you only wait at the inspection to find out, well, it doesn't assemble or it doesn't work. Well, maybe you have to think about how your assembly would work before in the design phase, where we can support also. So if we get on I think that's going to be the last slide. And before I go to the last slide, there's keep in mind when I'm after the last slide, when we're gonna go into the question of where you're gonna leave actually the conference. You can have a survey, please answer if you want to take 5 minutes. This is really good for us to develop content that is more interesting for you. Give us a really good idea of what was good and what wasn't so good within our presentation. We're open to critics, so please take just the 3 minutes it takes to answer those 5 or 6 questions. So last slide. So how does it work? How does dimensional management fits within your company or for your customer, for you, or within your channel of your business network? So what Crewform can do, actually today we've taken actually a case which is pretty simple. It was just to show an example and the different stages. We have tools and software at Crewform like 3DCS, which if you have a complex assembly, like let's think about a hood on a truck or a vehicle in the automotive industry. I mean, you might want to analyze the gap and flushness on the hood when it closed. So you want to make sure your gap is constant. You want to make sure it's flush with the fenders. So, and this is a 3-dimensional analysis. So it's not as simple as what we've shown today, but we have tools. When you get into more complicated stuff, we could do a demo maybe in the future of 3DCS, how it works. But actually what it does is you can take all your components, put all your tolerance on it in the 3D model, and then it would stack up all these possible variations. So there's a lot of possibilities, and then it would show you the worst case and the envelope actually of how it could look. So how your gap could look if your hinge is not properly is not within certain specification or is really at the end of a certain tolerance. Well, the impact it has when it closed, so it's not flush anymore, or the gap goes taper. So we can analyze all that and find out actually through your own assembly which is the greatest contributor to that failure actually of functional failure. So tools exist, we master them, and we have experts. So just keep that in mind. And there's different way we can work with you also if you need, because this is something you can do yourself. I mean, you can, if you have expert in-house, you guys can definitely go along and do it yourself. If you don't necessarily have that expertise, or for certain more specific stuff you don't, well, we can train you, we can coach you, we can be there to support you, but we can also do it all the way. So we can take the project and do it as a service offer. I mean, and it goes the whole thing. I mean, training is the most simple thing we can do, of course, but if you have requests all along the year, so we can have a bank of hours where you guys can just call us, say, hey, I have this specific problem. So we spend 20 hours trying to help you get through certain challenges, and then you can go with that. So depending on your level and where you want to get, we can support you through all these different phases. So there's either from the design to even if your product is already in service, we can support you. And we have also all the technology side of Crewform. We can inspect and take measurement on your different components. So that gives you the big pictures of how we can support our either distributor or even our end user or customer. So and that's pretty much what we wanted to show today. So at this point, we can take questions if you guys have, and answer them the best we can actually, and take some at least 10-15 minutes to answer them if you have any specific question related to your business or your products that you develop. So depending what exactly you guys are doing. Some of you are OEMs maybe, but some of you also are in the metrology reselling equipment. So don't hesitate to ask your question about how we deal with the dimensional management here at Crewform. So maybe I can take one here. Okay, so the question is, how do we do to find out if let's say if a stick, like you would, I guess it relates to the slide you had, Cédric, where how do you determine if it's the aesthetical gap is acceptable? So how to define criterion, I guess, for your variation analysis?
That was at the beginning, right?
Yeah.
Here.
Yeah, functional requirements. Yeah.
Yeah. So how do we go from that steps here? So the gap must be aesthetically pleasing and go to the correct requirement of 5 ± 2 millimeter. There's multiple answers to that. Depends very much on the specific of the situation. So for example, if it's a new product and you just don't know, you can just do the analysis without a target tolerance value, and have a look at what will be the true variation with that specific design. Or another way to do that would be if you have a certain product that with certain how could I say standard requirement. So let's say you produce vehicle and all of them have the same, you want all of them to have the same gap. You don't want one to look cheaper than the other. So you can develop a company standard that every gap of that type needs to be within that range, and it needs to be trial and error at the beginning, but you will build your expertise, and you will build some kind of a company standard on that.
Yeah, and then maybe I can add to that. There's some company will benchmark to other companies. So let's say in the certain industry, like in the automotive industry, you could have a company which is really has tight assembling components. So the gaps between the two doors, let's say, in the vehicle would be really tight. So maybe they invest more into to that aspect of their business and they control it better. Some will not. So you can also benchmark your competitors sometimes to figure out what seems to be acceptable. So on a certain amount of components, you say, well, they have certain typical variation. So they don't. I never seen a gap larger than X for this company. So let's say this could become also a standard for you. So you have to establish certain standards that makes sense for you, and there's some literature, I guess, also on that. Sometimes you can find what's acceptable or not. If it's aesthetic, it's more subjective somehow. If it's a gearbox, it's not. I mean, it's mechanical defined, so you can, by engineering purposes, by FE and all that, you can know what is acceptable or not. So it really depends. But for aesthetical, yeah, it's a bit more subjective. So benchmarking relative to the market, it may make more sense sometimes if you don't have any starting point. I don't know if that answers the answer. We have other questions. So what inspectional technology is useful for dimensional management? Actually, well, I can answer this one. There's more than one answer. So I guess if we're talking technology, there's inspectional technology. Either there's the hardware, so like for measuring stuff, so like the technology Creform develops or any other metrology equipment developer. I mean, there's a bunch of company out there. I won't name the competitor of Creform, but there's a lot of company that make CMMs or the portable CMMs, all kind of measuring device. It could be optical, touch probing, laser scanning, anything that can measure the technology can help you in their dimensional management process. As it's the fifth step, I would say, of the cycle. So measuring is the one thing, but also on the different aspect, more in the design phases, there's software that can be used to that. Like I mentioned on my last slide, there's a software called 3DCS that we use, but it's a software that makes virtual assembling. So you assemble it's kind of like a CAD software, but it's really dedicated to dimensional management. So you put your tolerances on every components. Normally in the CAD software, what you would do is just design nominal. So you design everything is nominal and the hole is right in the middle all the time. So what 3DCS will do, or a dimensional management software will do, is you can put a variation on that, and then you can virtually assemble with all the tolerances, and at the end of the day, what you end up with is a stack up of all these tolerances you have, and then you can make scenarios on how your product may vary depending which part is at the end of its own tolerance boundaries. So there are tools that exist to help company to go through the different steps. And I mean, maybe it's a good question. Maybe we can do a webinar someday on different technologies that exist to tackle all the dimensional management challenges. So I would say from our perspective, CAD model, 3DCS for variation analysis, and then we'll use technology like the handy probe to measure, and then Polyworks, which is the software for statistical and measuring, alignment, and everything, which is third party to us. And then you go back to the engineering and design. So I would say roughly like that: CAD, 3DCS, like a dimensional management variation analysis software, and then hardware and for probing or measuring, and then software like Polyworks for inspection report and everything. So that's what I have in mind in terms of technology needed. And then hope that answers the question. Got a few other here. How long does it generally take to complete I guess the cycle? So how long does it take to complete the cycle? So just an example, maybe depending on the product, of course, it varies depending on the industry. So Cedric, you want to answer that one?
Yeah, well, this one very can depend very much on the complexity of the product. So it can be very, very quick if that's a very simple product, or it can take a very long time if you have a lot of parts to analyze and a lot of complex relation between the parts. But you have to understand also all of these steps, they don't happen all at once. They are there throughout the whole length of the development and even during the production of the product. So it's more like these steps happen on over everything. So they are always there. And so if we take one step, for example, the requirement definition at the beginning. So this one is very fast. Usually, if you have a product that you reuse a lot, you know what are the requirements you generally want in that product. So it might be very fast to redefine the new requirement on a new product. But then the analysis might be a bit longer, because depending on if the product is complex or if it's just it's a small box that you want to make sure that everything is fitting correctly. It varies greatly depending. I think it's more depending on the type of the product than the industry, like the complexity of the assembly.
Yeah. Of course, if we take the whole cycle for, I don't know if I don't want to repeat, but if you make a train, it takes time to develop the train. So right from the beginning of the design phase, you're gonna have dimensional management in mind. So if you do the whole cycle, and it takes 2 years, 3 years to get the product to be first manufactured, well, you can imagine that the cycle time is long, since now you're going to start like manufacturing the product. So supplier send you the parts, and you assemble it within your factory. Then you find out you have certain issues, so then you have to inspect, make sure it's all okay, go back to the engineering. So a full cycle in this case might be years to do. Yeah. So, but if you make a small product, it could be really fast. If you do 3D printing and your design cycle is really fast, then the DM whole cycle is going to be faster. So it's directly proportional to your product design cycle.
And I think it relates a little bit to the next question also, which is dimensional management a design function?
Yeah.
Well, I think it's more like a philosophy that everyone needs to take into account. Like not only dimensional management, like we said, then doesn't happen only at the design phase. It also happens in the production, and everyone needs to be aware that it's there. So.
Yeah, it's a web. Honestly, like all we do, we have a lot. Creaform Engineering does develop product for your customers. So a lot of what we do is industrial design, CAD surfacing, CAD modeling, and trading 3D models, and I know developing products. But the DM is really all across the board. So it's we're gonna develop product which a company that makes trend, and then once the product is being assembled, so maybe 2 years later. Then they figure out they have issues on the production line. Some components are longer to assemble because the door doesn't close flush, and then, well, you have to find out what's the problem. So then you have to inspect. You make maybe laser trackers, or you use the IndyPro, whatever technology you use. And that the whole thing, you're gonna have someone like Cedric making sure you're taking the proper measurement, looking at the engineering drawings, making sure we understand the functional requirements. So it's everywhere. So it's not only design function. That's where it starts, but then so it's a function that's just really horizontal or somehow in the company. So it talks to all the departments somehow. Everybody it's physical, so it touched to the product physically. So it's your supplier might not be sending you proper parts, so you want to work with them to make sure he's able to deliver certain. So DM is really involved in very various fields. So it would be the it wouldn't be true to say it's only a design function. It's part of, but it's more than that. So like you said, it's a philosophy. So and then there's a few other questions. We're gonna take. Yeah, there's a bunch of them. Let me just read them. There's a long one. There's like a one which is very long. Maybe. Yeah,
it's about statistical analysis. Okay. Maybe I can take that one. Like, I don't want to go too deep into the details of statistical analysis, because it depends a lot on the specifics of each case. But the question is, when do you do worst case or statistical analysis? It depends a lot about first, how many parts are included in the stack-up analysis. So for example, if you only have 2 or 3 parts in your analysis, the statistical relationship between themselves is not that much. So the difference between the statistical analysis and the worst case tolerance won't be that great. But the thing is that you need to make sure of is that every single part in your stack-up analysis needs to follow normal distribution in the production of that part. What I mean by that is that if you want to have a statistical analysis on your tolerance stack-up, if all the parts, for example, are manufactured at the edge of their tolerance or outside of the tolerance, and then they are reworked up to the limit of the tolerance, that means that all the parts that you manufacture will be at the limit of the tolerance. So that means it won't follow a nice bell curve, a nice normal distribution. So in that case, you cannot use the statistical analysis in the same way. So there's a lot of specifics that needs to be.
And also, I think the question relates to the fact that like saying you could do it reverse way, so getting all the parts, making the statistical study and say this is the tolerance you should put. So functional requirements, let's say for aerospace engine, for a jet engine, could be very tight and very important. So what you make sure to say, once your engine starts turning, that there's no gap between your certain compression blades with the outside casing. It's a functional requirements. If you have a gap there, you're done. I mean, the engine won't be running and it's dangerous. So you cannot rely on the fact that your supplier or you internally are not able to produce that specific dimension. You need to be able to produce that dimension. It drives what the supplier or the manufacturer has to do. So yeah, and that's the engineering function, which is this is what it needs to be. And that's why sometimes in different industry, when it's less critical, you'll see tolerances on drawing that are way too tight, and then the guys on the production line will go, well, guys from engineering don't understand what we're doing. Doesn't make sense to make it that tight. So there's, I mean, DM is part of that whole, and GD&T is part of that whole communication thing where you say, well, maybe it's true. Maybe the guy on the production line is right. This doesn't make any sense. So you should change what's on the drawing. But let's say on a jet engine, most probably the engineer that did put the tolerance know what he's doing, and he's tested the engine before, so they know that you need to be within that specific tolerance. And there's customer that makes aircraft engines where they would have more than 100 CMMs in their facility, so they inspect at every stage of the process, and they have statistical studies for each step of their process. So let's say you're forging blades. I mean, at every step of the forging, you want to make sure and then they scrap the parts that are not good, that doesn't go through the tolerance, because they don't want to add more value to the part if it's not good at this point. So they track that at every stage of their production line. So some company will be very intensive in statistical studies and making sure it's within the tolerance, and some you can have more loose, and that's part of the design and the design portion and building sequence. The engineering team needs to know exactly what's important, what's not important, and to make sure you're not spending money on something that is useless, or make sure you're not taking risk at something which is really critical. So, and that's the engineering function. That's where our DM expert can help the engineer that develops the engine. So to work with them, making sure we're taking the proper decision. And there's other question, a few of them, so we can still answer a few of them, I guess. Maybe I'll take one. How do you evaluate the functionality of the product to properly do variation analysis? That's depend on the market, but yeah, if it's in jet engine, well, it has to function a certain amount, so the specifications are clear. If it's a product that is more like a consumer product stuff, well, it might be a voice of customer. So I don't know if you're producing I don't know, a casing for your iPhone. Let's take that as an example. You're producing a casing for an iPhone, and one customer out of 10 say the casing doesn't fit, or you have something loose on your casing. Well, I guess you're gonna feel like it's a bad purchase. So you might want to have tolerances that say you're never gonna have loose. So maybe sometimes it's gonna be tighter to put in, but never you're gonna feel like it's loose in your casing. So then that gives you an idea of the tolerance you should put. So you should have a tolerance that tells you either you're tight or you're fit, right? But it's never too large for your iPhone. So that gives you insights on what the tolerance should be, and then in terms of the value of it, in terms of nominally, like if it's plus or 1 millimeter or something, then that's more on the manufacturing process, or like if it's an elastic product, maybe versus a hard plastic, then you have to make an engineering decision towards that. Maybe so, like you want to add some more.
And a good way to determine that is maybe prototyping. So if you want, for example, to know what is the maximum in your iPhone case example, what is the maximum tolerance that the case can have to have a good feeling of the case, you can just prototype one case at the maximum of the tolerance, another case at the minimum of the tolerance, and if you are sure that it works in both ways, that will be the definition of the requirements. So there's multiple ways. If you are used to some kind of product, if you have prior knowledge, you may already know what is the tolerance that is acceptable for some kind of product. So it depends on your prior knowledge. If you don't know, a good way for easy product is just prototype the product at the edges of the tolerances, and you will be able to assess whether or not it will work.
There's okay, I think there's one question left. Well, just yeah. Well, I think that's the last we'll answer. Is it like if you see here, this one is, do you normally try to get actual parts assembly to evaluate the dimensional drift or functional dimensional drift?
I'm not sure I get this one. It's you mean physical? I think it means physical parts. So it can be done, but usually we when we do this work, the parts are not produced yet. So what we want to do is to try to analyze all of this before manufacturing the actual parts. That's where we can save the most money. But if we are in a debug situation, that's a thing that happen. Sometimes people call us where they have not done the work in the first steps, but we are in the manufacturing steps of the product, and we find that there is assembly problems. So in that case, yes, we can try to dry fit the parts and use the real parts to try to analyze.
And yeah, he's saying right from the first steps are usually missing from my experience. Yeah, honestly, it depends on how much intensive people are at designing at the beginning, but like something which is a great tool, maybe sometimes you don't want to have assembled everything. You have subsystems, or so what you can do is maybe, well, when you're in your FAI portion, sometimes when you PPAP process or you're qualifying your supplier, you can still have received a certain amount of parts, and so you can start doing some drifting there, I guess. But also with 3DCS, the software, once you get sometimes you have critical components that are more impactful on the rest of the assembly. So when you have that, maybe you can estimate on some of the portion, and then have real physical measure and statistical studies to input into 3DCS and see what's the impact on your whole assembly. So before doing the whole truck assembly, maybe what you want to do is on certain, say, oh, this part is really sensitive, it will have a lot of impact, so the whole assembly is really sensitive relative to this specific component. So we're gonna try to see if I have variation on this one, what it gives on the rest of the assembly. So that's what the software is used for. So instead of doing error and I would say that trials and errors, you could make some scenarios in the software, so you see if you have if you're really sensitive or less, or if there's measures you can do to become less sensitive to. If you think a supplier you're not sure is going to be able to do something, so let's make some scenarios. If he's not able to supply that specific dimension on a really good way, let's say you have a plastic part, maybe more flexible, so you want to see if you have there's a way to attenuate that impact. That's where the software is really useful, and that's the variation analysis portion of the the process. So
because on a new design, like you said, we don't have a true physical part until maybe that step right here, the GD&T steps, inspection steps, in fact. So yes, that's true. We have a lot of most people raise their hand right here at the end.
yeah, when it's kind of like too late. Also, there's a lot of invested when you're there. There's a lot of money invested already. So you have
the more
physical
you raise,
components. Yeah,
the higher it costs. So
it's true with simulation. It's not specific to dimensional management. I guess sometimes in the product development process, people tend to, if you tend to be really cheap at the beginning or trying to reduce your cost, sometimes it's going to impact more on the future since you're more involved. So you have your arm up to the shoulder instead of having it to your wrist. So now you're stuck and you have to deal with that. So, but I guess everybody knows that. But it's trying to figure out using the proper tools at the proper moment and to maximize or being as much efficient as you can. So, but sometimes, I mean, it's still validating if it's all functional. You're gonna have to assemble and roll the truck or fly the aircraft at the end. So, but then doing heavy measuring on large assemblies it costs more. So that's the whole point. So you maybe want to reduce that to the minimum. So that's I guess that's it for today. And thanks for the interactions. Really great to have questions and to be able to share that with you. And like we said before, at the beginning of the presentation, this is a first stuff. So introductory for GD&T and dimensional management, but we might get into more variation. I guess variation analysis might be super interesting for some people from what we've seen, maybe more technical into software and application studies in specific fields. Maybe if you work in the automotive or some industry and you have stuff that you would like to see more specific, well, we're open to your suggestion and we will try to develop content. So we'll be happy to have more session in the future. So, well, thanks for your participation and hope you enjoyed the whole presentation. And for more info, go on our website or you can send us email at me or Cédric. Can go on our website also. There's some case studies and stuff and show what we can do and all the offer we have at Crewform Engineering to support product development and manufacturing solutions. So that's it for today, and hope we're going to see you on the next webinar. Thank you.